a website for monitoring children's growth. Here is the tutorial. Happy watching!
First, let's understand how the entire system works. Whenever a user opens the website, the browser sends a request to our PHP web server. The PHP application is responsible for displaying pages, processing forms, and communicating with the database. The database stores important information such as user accounts and baby profiles. For stunting prediction, we use a separate Flask API. PHP sends child data to the API, the machine learning model performs prediction, and then the result is returned to the website. The architecture is commonly used because each component has a clear responsibility. PHP handles the website, SQLite handles data storage, and Flask handles machine learning. Now, let's organize our project. First, create a folder called Auth. This folder will contain files related to login, registration, and password recovery. Next, create a profiles folder for baby information. Then, a monitoring folder for KPSP assessment. Next, a recipes folder stores MPASI related pages. And then, machine learning folders contain files that communicate with the Flask API. Finally, the asset folder stores CSS, images, JavaScript files, and other resources. Then, let's create the database. Database is where all information will be stored permanently. The first table is the users table. Inside this table, we create columns for user ID, full name, email, and password. The user ID serves as the primary key, meaning every user has a unique identifier. Next, we create the babies table. This table stores information about a child, including name, birth date, gender, height, and weight, and etc. Notice that we also store the user's ID. This creates a relationship between parents and their children. Later, when a parent logs in, we can retrieve only the child profile that belongs to that specific account. Here we can see the baby's table and the user's table. Let's build the registration page. The first thing we need is an HTML form. This form contains inputs for the user's name, email address, and password. When the user clicks the register button, the form sends data to PHP using the post method. Inside PHP, we retrieve the submitted values using the post variables. Before saving the data, we validate the inputs. For example, we check whether the email field is empty or whether the password meets the minimum requirements. Next, we hash the password before storing it in the database. Finally, we insert the data into the user's table. If everything works correctly, the user receives a success message and can proceed to the login page. Now, let's build the login interface. The form is simpler than the registration page because we only need an email and password field. When the login button is clicked, the entered information is sent to the server. Now we add the authentication logic. First, PHP receives the email and password entered by the user. Next, we search the database for an account with the matching email address. If no account exists, we display an error message. If the account exists, we verify the password using the password verification function. This function compares the entered password with the hash password stored in the database. If they match, we create a session. A session allows the website to remember the user is logged in. After the session is created, the user is redirected to the dashboard. Let's create a recovery page. The page contains a simple email input field. The user enters their registered email address and submits the form. The system would send a password reset link via email. Continue to the baby's profile page. The form includes the child's name, birth date, gender, weight and height, head circumference, arm circumference, vaccine history, allergies, and etc. When the save button is clicked, the information is inserted into the database. After saving the data, we display it inside the profile card so users can quickly review or add the new information. Next, we create the developmental monitoring feature using KPSP. The KPSP questionnaire contains several age-specific developmental questions. For each question, users can answer yes or no. Inside the code, we assign scores to the responses. As the user submits the form, PHP calculates the total score automatically. Based on the score range, the system determines whether the child developmental is appropriate, full, or requires further attention. Finally, we display the result in easy-to-read summary section. Now let's build complementary feeding recipe or MPASI page. First, we create a database table containing recipe information. Each recipe includes its title, age category, ingredients, and preparation instructions. When users visit the page, PHP retrieves all recipes from the database and displays them as cards. To improve usability, we add filtering options. For example, parents can view recipes specifically designed for babies aged 6 months, 8 months, or 1 year. Now let's move to the machine learning component. The purpose of the model is to predict stunting risk using child growth data. We begin by training a machine learning model in Python. The model learns patterns from historical child growth datasets. After training, we save the model into a file so it can be loaded later without retraining every time. Next, we connect the website to the machine learning service. When users submit a child's information, PHP collects the data and converts it into JSON format. The JSON data is sent to the Flask API using an HTTP request. Inside Flask, the machine learning model receives the data and performs prediction. The prediction result is then returned to PHP. Finally, PHP displays the result on the website. Finally, let's build the nutrition calculator. Users enter the child's age, weight, and height. PHP receives these values and performs calculation. The system can estimate nutritional status and provide recommendations. Now, let's take a look at the final SiKecil website. This is the SiKecil dashboard, the central hub of the application. We begin at the register page. After that, we go to login page. Once the login process is successful, users are redirected to the baby's profile. Next, we go to Growth Monitoring or KPSP page. The system presents age-appropriate developmental questions that parents can answer based on their child's abilities and behavior. Once all questions have been completed, the system calculates the score and evaluates the child's developmental status. Next, we go to stunting detection using machine learning. Here, users enter the child growth, including age and height. The model analyzes the input data and predicts the child's potential stunting risk. Within seconds, the prediction result is displayed on the screen. And the last feature is recipe nutrition recommendation. Parents can browse various complementary feeding recipes tailored to different age groups. Each recipe includes ingredients and preparation instructions, making it easy for parents to prepare nutritious meals at home. In conclusion, SiKecil provides a comprehensive digital solution for monitoring child growth and development. By combining healthcare monitoring with modern web technologies and artificial intelligence, the platform aims to support parents and healthcare professionals in promoting healthier childhood development. Thank you for watching, and I hope this tutorial helps you build your own impactful applications.